All right, now lesson 80. We're going to look at segment relationships in circles. That's going to be chords, tangents, and secant lines and segments. Okay, we're going to start off with two chords. Now we already did two tangents. Actually, I want to kind of a little side note here. We already did two tangents. So if you ever see that, right? Remember I can't draw. Something like that, right? Two tangent segments where they hit at one point, right? They're outside the circle. Two tangents come together to an external point. Okay? They are going to be equal in measure. They're the same length. That's an easy one. We kind of did that in our introduction with circles. Now we're doing the other intersections. Now we have two chords, and then we have two secants, and then we're going to do a secant and a tangent. All right, and those are all our different relationships. So here's the formulas. All right, they're not really formulas. They're just, you just have to know what to put where and what the relationship. They're really relationships. They're not really formulas, but they kind of are like formulas. So if you got to look at the picture and then look at the relationship, and they tell you how to figure out or what the relationship is. So this says AB, right? AB is this right here, okay? AB times BC. Now BC is this piece here. So you basically multiply those two, all right? You multiply those two pieces, which are the two pieces that make up the one chord. And then it equals DB, which is this piece here, okay, times BE, which is this piece right here. So you multiply the two pieces of the chords by each other and set them equal to each other. And that's the relationship within two chords intersecting. So very simple, actually. This is probably the easiest one. So here's an example, all right? I have 20 and I have X. 20 and X make up the one chord. So it's going to be 20 times X equals. You see? You don't even need the letters, right? You don't need A, B, C, D, and all that. It's just this piece here, this piece, times this piece equals this piece times this piece. So equals 12 times 15. You just got to know the relationship. All right, so 20x equals, and this is 180, and then divide by 20, and x equals 9. Just solve it out. Pretty simple. Now, before you do this one here, here's another example. We know it's going to be this times this. So we know it's going to be 1.2. I'm running out of room. It's going to be 1.2. I'm going to use parentheses just because I have decimals. 3.3. I know it's going to be that times that. What's going on here, though? They didn't give me this or this. But I have a diameter perpendicular to a chord. I have a diameter perpendicular to a chord. We learned that that forms a right angle, and which they showed, right? And we learned that that bisects the chord. That's one of our theorems. So if this is x, this must also be x. If this is 4, this is 4. If this is 5, this is 5. The chord is bisected. Chords are bisected by the diameter when they are perpendicular. That's a very important thing to know. So it's going to be x times x. I don't know what x is, but whatever it is, you times by itself. So now I can solve this because this here multiplies out to 3.96. And then this is x squared. All right, and then I just take the square root of both sides, and x is approximately 2. It's like 1.99 or whatever, so we're just going to call it approximately 2. All right, so it's 2, 2. All right, and that's basically how that works. Now, two secants. Two secants are when two secants intersect outside the circle. And we've seen this situation before. But now we're not talking about the angle. In another lesson, we talked about what's this angle measure in relation to the arcs. We're not doing that anymore. We're not talking about angle measure. We're talking about the lengths. How long is this compared to this, compared to this, compared to this? All right, well, that's not exactly how it works, but that's kind of what we're talking about. So it's AB, so it's this piece, times AC. AC, that's this whole piece here. Multiply those, it equals AD times AE. AE is the whole piece. So it's the outside times the whole secant equals the outside times the whole. So you might want to write that. It's the out times the whole equals outside times the whole. All right? Outside times the whole equals the outside times the whole. Two different segments. So we'll apply that now. We have the outside, which is 5, okay? So we have, and you could squeeze it over here wherever you have room. You might not be able to do it below the circle, but you might be able to have to do it over here. All right, so it's going to be 5 times the whole secant. 5 and 7, that's 12. It's not 5 times 7. Most common mistake. Students go 5 times 7. They're not thinking. It's the outside times the whole thing. Equals outside 6 times the whole thing. The whole thing is, piece it together, x plus 6. All right, if you weren't sure, it's x plus 6. All right, so this is 60. And then you got to distribute your 6. 6x plus 36. Now I'm going to subtract 36 to the other side. Right, just a basic equation now. Divide by 6. X equals 4. So the x is 4. This is 4. That means the whole piece is 10. See, so you got to make sure you answer the question. Do they want the whole piece? Do they want just x? In this case, they just wanted x. How about this one here? So now I have this, but then here I have 12. And now see the little double hash mark there? That's telling you they're congruent. So if this is 12, this is also 12. This is a little trick there. All right, so it's outside times the whole thing. Not 12 times 12, 12 times 24. The whole thing's 24. All right, this whole thing was 12. And then 10, the outside, times the whole thing. The whole thing is x plus 10. All right, so this is going to be 288 equals 10x plus 100. Subtract 100, you get 188 equals 10x, and then divide by 10, and that's going to be 18.8. So 18.8 centimeters would be the length of x. All right, and then last one, well, that last, well, yeah, I guess last relationship is one secant and then one tangent. So it's like a picture like this, or like this, or like this, or like this. It's AD, that's the tangent segment, times AD, so times itself. It's the tangent times the tangent. And then AB times AC, the whole thing. So that's at least the same, right? So essentially it's outside, it's the same thing. It's outside times the whole equals outside times the whole. The outside piece times the whole piece. But it's just that the tangent, right, the AD is both, right? Because the outside piece is the whole piece. That's all there is. There is no inside piece. So the outside is the whole. So these two things are equal when you're talking about a tangent. That's really all that's different. So it's almost the same as the one before. All right, so outside, right? Outside times whole, 8 times 8. 8 times 8 equals 4 times the whole thing, which is x plus 4. You got to make sure that goes in parentheses because then you got to distribute. So this is 64 equals 4x plus 16. And then subtract 16 and divide by 4. It ends up being 12. It ends up being 12. So this piece here is 12, and then the whole piece is 16. All right. Next one here, outside again is 12, so it's 12 times 12. Oh, no, not again. I don't know why I said again. The outside piece is 12. And then here the outside piece is x. And then the inside piece is 10. The whole thing is x plus 10. So now that's going to create an x squared here. This one's going to get a little nasty. X squared plus 10x. Uh-oh. Now I have an equation with x squared and also x. Now I got to use my algebra skills. My algebra skills say to get it equal to 0. I got to get this equal to 0 minus the 144 over. So now it's 0 equals x squared plus 10x minus 144. And then you can factor it. Oh my goodness, we've hardly done any of that this year, right? Well, you should know how to factor something basic like this. It would be x plus 18 and x minus 8. I know you probably wouldn't come up with that fast, but you could figure out factors of 144 that give you a difference of 10. And it's going to be 18 times 8. 18 times 8 is 144. 18 minus 8 is 10. All right, so then you set those equal to 0, and you get x equals negative 18, and you get x equals positive 8. But how could this be a length of negative 18? You can't have a length of negative 18, so I'm going to reject the negative 18, and we're going to say that the length must be 8. Negative 18 is not a possible answer, really, so it's got to be 8 because you got to have a positive value. All right, so x equals 8 in that case. Last one, outside times outside, which is going to be, in this case, x times x on the outside. And then this is going to be 9 times the whole thing, 36. 9 times 36. So this is x squared equals 324. And then take the square root. And that is a perfect square of 18. So the x would be 18. All right, so individually, I think these are pretty easy. It's just remembering the relationships and setting them up properly when you're on, say, a quiz or test or an exam, and keeping them all straight and what goes what and where and when and all that. So once you get set up, the solving of it's pretty simple. All right, we'll see you tomorrow to practice these.